Before we plunge into the declaration, it's critical to comprehend what molecule gas pedals are. The enormous Hadron Collider, LHC, worked by CERN, is a 17M ring of superconducting magnets and the world's biggest and most remarkable atom smasher. It represents the zenith of human logical accomplishment. Truth be told, it's so powerful that it can reproduce the actual states of the universe's introduction to the world. Yet, could this machine, designed to unlock the secrets of the universe, hold the key to something far more ominous? CERN, established in 1954, is one of the world's most prestigious research organizations, with 23 member states and thousands of scientists. It's a hub for collaboration and innovation. The LHC is CERN's flagship project, yet it's only one part of a vast network of accelerators and experiments. Imagine a circuit, not for cars or horses, but for subatomic particles, in a race against time and space itself. The LHC accelerates protons to nearly the speed of light, sending them on a collision course that mimics the energy of the universe at the time of the Big Bang. The collisions generate temperatures over 100,000 times hotter than the core of the Sun. Thousands of magnets guide the protons on their journey, while intricate cooling systems keep the magnets at temperatures colder than outer space. The beams inside the LHC are designed to collide at 4 points around the accelerator ring, corresponding to the locations of 4 particle detectors: Atlas, CMS, ALICE, and LHCb. Each serves a unique purpose, exploring different aspects of particle physics. Together they act as massive cameras, capturing snapshots of these collisions. Scientists then sift through the debris, searching for signs of the elusive Higgs boson, also known as the God particle, and other phenomena that offer clues to the universe's fundamental building blocks. By studying the microcosm, we gain insights into the cosmos. Yet, with each answer comes another question, and with every discovery, a new challenge. The LHC isn't just a scientific instrument. It's a testament to human curiosity and innovation. It embodies our relentless pursuit of knowledge and our desire to understand the fundamental forces that shape our universe. But as we push the boundaries of what we know, we must also consider the ethical and existential questions that arise. What are the risks of probing the unknown? Could our quest for understanding inadvertently unleash forces we cannot control? In the sacred halls of CERN, where the limits of human understanding are constantly tested, a revelation has emerged that sends a shiver down the spine of even the most seasoned scientists. Brian Cox, a former researcher at CERN and a prominent voice in the field of particle physics, recently made an announcement that has left the world both fascinated and fearful. Cox's words resonate with haunting clarity. The goal of CERN's Large Hadron Collider is to recreate a miniature Big Bang. Yes, you heard that right, a small-scale version of the very event that birthed our universe. The physicist went on to explain the implications of this goal, highlighting the LHC's extraordinary potential for groundbreaking discoveries. This includes its ability to unlock the mysteries of the Higgs boson and explore dark matter, a mysterious substance that constitutes a significant portion of the universe. Imagine harnessing the power of creation, the ability to summon the very essence of the universe. It's an enticing prospect, but one fraught with danger. The miniature Big Bang isn't a theoretical concept. It's a tangible reality within the LHC. The temperatures, pressures, and raw energy all mimic the conditions of the universe's infancy. It's like standing at the dawn of recorded history, witnessing the birth of existence itself. Yet, with such power comes responsibility, and the question looms: what if something goes wrong? In fact, something did go wrong back in 1978. Russian physicist Anatoly Bugorsky experienced a catastrophic accident that forever altered the trajectory of his life. While working on the UB-70 synchrotron at the Institute for High-Energy Physics in Protvino, Russia, a malfunction led to his head accidentally being exposed to a proton beam. The beam, with an intensity that defies comprehension, passed through his skull, entering the back of his head and exiting through his nose. Bugorsky's experience was miraculous. He saw a flash brighter than 1,000 suns but felt no pain. The beam's path left a trail of destruction, burning through tissue and bone, yet he remained conscious and even walked to the clinic for treatment. The aftermath was both horrifying and fascinating. The beam's path caused localized tissue death, leading to the loss of hearing in one ear and partial facial paralysis. Yet, astonishingly, Bugorsky's intellectual abilities remained intact, and he continued his scientific career. This incident is not just a personal tragedy but a cautionary tale that underscores the immense power and potential danger of particle accelerators. The risks of an atom smasher like the LHC are not to be underestimated. The potential for unforeseen reactions, the manipulation of the very fabric of reality. These are not the stuff of science fiction but real concerns voiced by some in the scientific community. One of the most unsettling and captivating concerns associated with the LHC's experiments is the possibility of creating a miniature black hole. Black holes are regions of spacetime where gravity is so strong that not even light can escape. They are cosmic vacuum cleaners, devourers of stars, enigmatic entities that lurk in the shadows of our universe. That the LHC could create such a phenomenon even on a microscopic scale is both astounding and alarming. Could this black hole grow uncontrollably, consuming the Earth from within? Scientists at CERN have assured the public that any black hole created would be unstable and dissipate instantly. However, the remote possibility has ignited debates, fears, and a sense of awe at the power we wield. It's crucial to understand how the LHC could create a black hole. It has to do with the fundamental mechanics of particle accelerators. When protons collide at nearly the speed of light, the energy released is so immense that it warps the fabric of spacetime itself. Imagine a trampoline stretched tight, and then a heavy object is dropped onto it. The fabric bends and distorts, and if the weight is heavy enough, it could create a depression so deep that anything nearby would be drawn into it. This is a simplistic analogy for what could happen in the LHC. In the realm of quantum physics, where the laws of the universe are both unpredictable and beautiful, there exists a theory that extra dimensions may be hidden within our universe. If these dimensions exist, the LHC's collisions could tap into them, creating a gravitational well that forms a tiny black hole. This mysterious dance of particles has even drawn the attention of world-renowned scientists, particularly the late Stephen Hawking. In his work, he warned of a scenario where the Higgs boson could become unstable at extremely high energy levels. This instability could lead to a catastrophic vacuum decay, a cosmic event that would not only destroy the Earth but the entire universe itself. Respected British cosmologist and astrophysicist Sir Martin Rees also expressed his concerns about the experiments conducted at CERN. In his book on the future, Prospects for Humanity, he explored the potential risks associated with atom smasher experiments, including those at CERN. His words were not merely cautionary. They were tinged with a sense of existential dread. He spoke of a worst-case scenario where a catastrophic experiment could create a condition known as vacuum instability. This instability could, in theory, trigger a phase transition that would echoes through the actual texture of spacetime bring about an enormous calamity that could overwhelm the whole universe. Rees's interests were not restricted to hypothetical thoughts. He relegated a likelihood to these disastrous results, a low one. Yet, even a minute possibility, he contended, ought to give us pause. The stakes are unbelievably high, and the margin for error is razor-thin. The researchers at CERN have calculated the probabilities, run the simulations, and examine the theories to argue for the safety of the LHC. In fact, Brian Cox himself acknowledged the importance of responsible analysis, recognizing that there are widespread fears and concerns surrounding the LHC's activities. He emphasized that there are rigorous safety measures in place, extensive reviews, and protocols ensuring that the LHC's operations are conducted with extreme care. Cox reassured that the energies involved are well within what the Earth naturally encounters, and that the chances of creating a stable black hole are astronomically low. Even if one were created, scientists say it would be so small and so unstable that it would dissipate instantly into energy, a phenomenon predicted by Stephen Hawking known as Hawking radiation. It would be a brief moment of cosmic wonder, a glimpse into the abyss, and then gone. Some have speculated further, imagining that the LHC's experiments could open a doorway to another universe or dimension. This idea, though largely dismissed by mainstream science, has captured the imagination of many and has become a subject of intrigue, fear, and even folklore. What lies beyond our universe? Could we inadvertently unleash forces or entities we do not understand? The notion of opening a portal to hell has been dramatized in various media, fueling uncertainty. But how did this idea arise, and what does it mean in the context of scientific exploration? The concept of parallel dimensions is not new in physics. String theory, a leading contender for a unified theory of everything, posits that there may be more than the familiar three dimensions of space and one of time. These additional dimensions could be compactified or hidden from our perception but could theoretically be accessed or revealed under extreme conditions. Now imagine the LHC as a cosmic key, unlocking doors that have been sealed since the earliest days of recorded history. When protons collide at energies never before achieved on Earth, they could, in theory, create ripples or tears in the fabric of spacetime, giving us a glimpse into these hidden dimensions. This idea has sparked both awe and fear. It's not just the possibility of creating black holes that haunts us, it's the potential for opening the gateway to the unknown. As we venture further into the realm of particle physics, we are faced with profound questions about our place in the universe. Can we control what we discover? And more chillingly, can we close the door once it has been opened? The announcement made by Brian Cox about the LHC's goal to recreate a mini Big Bang should be a moment of scientific triumph. But, as with all great advancements, it comes with its share of risks and uncertainties. With each new discovery, we edge closer to the brink of the unknown. In this quest for knowledge, we must remain vigilant and cautious, for the greatest discoveries are often those that leave us questioning whether we should have looked at all. Brian Cox's declaration about the LHC's objective to replicate a mini Big Bang resonates throughout the scientific community. It serves as both a beacon of achievement and a source of existential reflection. The ambition to simulate conditions like the birth of our universe, to glimpse into the very origins of spacetime and matter, is an extraordinary leap in human exploration. Yet, as we journey further into the cosmos, we must confront the profound responsibility that comes with such power. The LHC is a technological marvel, a symbol of humanity's ingenuity. Its purpose is not just to probe the fabric of the universe but to uncover the delicate balances and mysteries that govern everything we know. By smashing particles together at unprecedented speeds, scientists can study the fundamental forces and particles that shape the universe, from the Higgs boson to dark matter. However, every experiment, no matter how carefully controlled, carries unknown variables and unforeseen risks. The fear of accidentally triggering a catastrophic event, such as creating a stable black hole or collapsing the quantum vacuum, reflects deeply rooted anxieties about the potential downsides of scientific discovery. While the chances of such a disaster are minuscule, the implications of even a small risk are terrifying. The world has already witnessed the destruction human actions can bring, from environmental crises to nuclear bombs. Now, the fear is that we may be tampering with forces far too vast for us to comprehend or control. Despite the potential dangers of the LHC, there is an ongoing philosophical question. What is the cost of knowledge? Are we willing to face the consequences of delving too deeply into the fabric of reality, of possibly uncovering forces that were meant to remain hidden? What if, in our quest to understand the universe, we trigger a chain of events that spiral out of our control? In the pursuit of scientific progress, it is crucial to balance curiosity with caution. While the LHC has brought us closer to understanding the fundamental components of nature, it has also prompted us to reconsider the ethical implications of tampering with the very building blocks of existence. Opening portals to other dimensions, whether accidentally or by design, presents a speculative yet fascinating concept that stretches beyond the realm of hard science. Could the collision of particles at such high energy tear open the fabric of spacetime, potentially linking our universe to others or exposing us to entirely new forms of existence or unknown forces? The very possibility raises unsettling yet compelling questions about the nature of reality itself. Are we truly prepared to face what might lie on the other side? Or have we already crossed a point of no return in our quest for knowledge? At the same time, it is important to note the assurances of scientists involved in the LHC's experiments. They have repeatedly stated that the safety protocols and thorough risk assessments conducted at CERN ensure the utmost caution. The likelihood of a catastrophic event is minuscule, they argue, and the energy levels involved, though extraordinary by human standards, are not unprecedented in the grand scope of the universe. For instance, similar collisions occur naturally in cosmic phenomena such as supernovae. In summary, the work being done at CERN is a testament to humanity's boundless curiosity and drive to understand the universe. However, with great knowledge comes great responsibility. The very forces that allow us to unlock the mysteries of the universe also have the potential to alter everything, from the structure of spacetime to the fate of our world. We must approach this frontier not with hubris but with humility, mindful of the vast unknowns that lie ahead. As Brian Cox and his colleagues continue their work at CERN, the world watches with awe, curiosity, and a touch of fear. What lies ahead in our quest to recreate the Big Bang? Only time will tell. One thing is certain: the pursuit of knowledge is a profound journey, one that may one day lead us to the very edge of existence itself.